Hi folks, in the last video you looked at how we solve what we call linear inequalities. Okay, so say you have something like 2x plus 7 is less than 4. Okay, so essentially you're determining the x values for which the left hand expression is going to have a value less than the right hand expression. And you saw that you could solve this in a very similar way to solving a linear equation, which was using opposite operations. Okay, so now we're going to move this up to polynomials. So let's say our goal is to determine when the y value here is going to be less than 3. Okay, so what we have is, not surprisingly, a polynomial inequality. Okay, now similar to polynomial equations, we're not able to solve those for the most part using opposite operations and isolating the variable directly. Okay, so we're going to see if we can recycle some of our methods for solving something like this. Okay. Now you've already been solving polynomial inequalities, because think about it. You've been solving for when a function is greater than or equal to 0. So let's say I want to solve for when a polynomial is greater than 0. We use the fact that a polynomial can only change sign at an x-intercept. Okay, so the goal here was to factor f at x, determine the x-intercepts, and once we have the x-intercepts, you can just draw a graph of that particular polynomial and read off the graph when it's greater than or less than 0. Okay, and we're going to see that we can generalize this very easily to solving a polynomial inequality. Okay, so not surprisingly, what I'm going to want to be solving is not when an expression is greater than or equal to a number like 3 or 7 or 14, is I'd like to just turn it into a problem of determining when it's greater than or equal to 0. So again, exactly the way we would solve a polynomial equation, I'm going to rewrite this inequality so that I've got 0 on one side. Okay, and as we saw in the last video, we can perform opposite operations on inequalities. So we can add or subtract a number to both sides. We can multiply or divide a number to both sides. Just keeping in mind that if I multiply or divide a negative number, I have to switch the inequality. But here, in order to achieve what I need to achieve, I'm just going to subtract 3 from both sides. So I'm left with this inequality here, x to the 4th plus 2x squared minus 3 less than 0. So essentially, if I think of this as a function f, okay, I'm just determining when this function happens to be less than 0. So I'm going to apply the exact same methods as I would have before. Okay, so first things is to try to determine the x-intercept. So we're going to do that by factoring, and I see here a quartic trinomial. So I should be hoping that I can factor this as a trinomial. In this case here I can't, because I have x squared. So I need to get to plus 2. So I have x squared plus 3 times x squared minus 1. Okay, and now I look at that first expression, I realize that not only is it not factorable, but it doesn't generate any zeros, because if I were to solve this equal to 0, I get x squared equals negative 3, which can't be solved. So that's as far as I can go with this one. Okay, and here of course I have a difference of squares. Okay, and so now I have this factored expression. I have to determine when that's less than 0. And as we said, the only place it can change sign is at an x-intercept. So, as we did before, I'm just going to use a graph. Okay, in this case here, I'm not even going to bother with a y-axis. And the only place that this expression can change sign would be at 1 and at negative 1. Okay, so here I have a quartic polynomial with a positive leading coefficient, so I know my graph will look something like this. You know, maybe the function does something funny there, maybe it doesn't, but we're not interested in that. We're just interested in when this function is greater than or equal to 0. Okay, and I see that, can read right off my graph that it's negative only between negative 1 and 1. And so now I can give my solution. I'm going to use interval notation. And notice here, I'm not going to be counting negative 1 and 1 because I want it to be strictly less than 0. So my answer here is just going to be from negative 1 to 1, not including the endpoints. Okay, so just a recap. Okay, solving a polynomial inequality is very similar to solving a polynomial equation. Step number 1 is going to be to move all terms to one side of the inequality and have 0 on the other side. Step 2 is to factor or find a way to determine the zeros. It might be using the quadratic formula of that function which is left over on one side of the equation, or sorry, the inequality. Okay, and then sketch the graph of that polynomial to determine when it's greater than or equal to 0. Okay, that's it for now.